The Elements of Non-Euclidean Geometry by D.M.Y. Sommerville.
Chapter 1, Historical. Section 6, Bertrand's Proof of Infinite Areas. Another class of demonstrations is based upon considerations of infinite areas. The following is Bertrand's proof. Let a line AX, figure 3, proceeding to infinity in the direction of x, be divided into equal parts AB, BC, and so on, and let the lines AA', BB', and so on each produce to infinity. Make equal angles with AX. Then the infinite strips A', B, B', B', C', etc. can all be superposed and have equal areas. But it requires infinitely many of these strips to make up the area A'AX, containing between the lines AA' and AX, each produced to infinity. Again, let the angle A'AX be divided into equal parts A'AP, PAQ, and so on. Then all these sectors can be superposed and have equal areas. But it requires only a finite number of them to make up the area A'AX. Hence, however small the angle A'AP may be, the area A'AP is greater than the area A'BB', and cannot therefore be contained within it. AP must therefore cut BB', and this result is easily recognized as Euclid's axiom. The fallacy here consists in applying the principles of superposition to infinite areas, as if they were finite magnitudes. If we consider figure 4 two infinite rectangular strips A'A, BB', and A'P, Q, B', with equal bases AB and PQ, and partially superposed, then the two strips are manifestly unequal, or else the principle of superposition is at fault. Again, suppose we have two rectangular strips A'A, BB', C'C, D', figure 5, mark off equal lengths A1, A2, and so on along AA', each equal to CD. The equal lengths CC1, C1, C2, etc. along CC', each equal to AB, and divide the strips at these points into rectangles. Then all the rectangles are equal, and if we number them consecutively, then to every rectangle in the one strip there corresponds a similarly numbered rectangle in the other strip. Hence, if the ordinary theorems of congruence and equality of areas are assumed, we must admit that the two strips are equal in area, and that therefore the area is independent of the magnitude of AB. Such deductions are just as valid as the deduction of Euclid's axiom from a consideration of infinite areas.
The Elements of Non-Euclidean Geometry. This book was written by D.M.Y. Sommerville, M.A. and Doctor of Science. It was published by the Open Court Publishing Company, London, G. Bell & Sons, Ltd. in 1919, and now is in the public domain. It is being read by Jim Renholt, with programming and illustrations by Jim Renholt in 2019. Thank you for listening.